simulate it on the computer, very much the same as worrying about how a boat pulls up to a dock. It'll recognize where the appropriate slip is. But what makes this different than the boat docking problem is that we have a very oddly shaped slip, the hole in the lock, if you will, and we have to make sure we put just the right key in there. Because if the key that we put in doesn't fit, you don't get the desired activity at all. And if we have a key that can fit into multiple locks, you begin to
streamline the process by identifying which particles have the highest potential for success. And because these models help researchers to see substance.
Another one was working on a class of molecules which are involved in treating of cancer, certainly laboratories. When they came back, they inadvertently got on each other's terminal. And about 15 seconds later, the first one yelled out, "What are you working on my class of compounds for?" I said, "I'm not." And he said, "Yes, this is my compound over here." What came out of this was there was a similarity before, because the way we've been used to drawing these structures on a sheet of paper is in a stylized representation, which is really almost artificial. And you would have never seen that similarity. But when you displayed them exactly as emitting some of our weed killers to the National Cancer Institute for screening.
Understand events and processes that we cannot see or touch directly. To develop a model, the scientist starts with observations. These observations are used to form a mental representation, a model, of the process being studied. Then the model must be tested. One important chemical model is the kinetic particle model